When I was first getting into electronics a long time ago, when I was a child, I needed a power supply, and one of the first projects I made was this power supply. And this is adjustable. I think it's 1.5 to 15 volts, and it's up to, I think, 2 amps. And I'm not sure what happened here. This whole, I may have drilled that too close to the corner for this potentiometer. But at the time, it did the job. What I found lately, though, many decades later, is that this voltmeter has become very inaccurate, and if the output is 12 volts, it will indicate about 9.5. And so that got me started on this this kind of new project to rebuild this power supply. I've already taken the meter out. Let's look at the back here. So, I put the regulator on the back, right on the case to radiate the heat. And then I've got these terminals that take, a bullet connector, or they unscrew, and the wire can go right down in the slot there, which is great. So I'd like to reuse those, but I'd like this to be more than 2 amps. I think I will upgrade it to 5 amps. And you can see this was built many years ago, and looking forward to having a supply with an accurate meter and make it more capable at the same time. So let's take this apart and review the really interesting construction at the inside. How I connected everything together, mounted all the components. Basically representative of what a child would do without much guidance, which is exactly the situation I was in. And I've got a hole down here. I don't know what that's for. Extra holes must mean some changes were made over time, or it was a mistake. This case was only used for this power supply, so I'm sure that hole was not for some other project. Okay, so inside this really awesome power supply from the Stone Age, you can see this brilliant wiring. The transformer here is bolted through the bottom, which is good because it weighs about a pound just by itself, and then everything else is secured to it by solder. So all of these components are just held in there by the wiring connections. I'm not sure how good of a splice that is, but that looks like the wire was too short, and I must have changed my mind or something. But I think I had that meter in here the whole time from the beginning. So. This is old. It works. So all I think I need to do is replace this regulator with a 5 amp adjustable regulator, which is available. Another thing that I didn't like about this, recently I realized that I had made a note up here that the right down here, positive is connected to the case. So if you are working on powering up a project and a ground wire happens to touch the case, you get a nice short circuit, which could cause damage, fire, sparking certainly would make me jump if that happened. So I want to resolve that, and the reason that is all of these regulators, the output voltage is connected to the case. So by mounting it to the case for heatsink, I've connected the output voltage right to the entire case. So what I need to do is isolate this from the case, probably mount this to a heatsink and mount that to a board, and mount the board to the case instead of the way I've done it a long time ago. So I have this nice, another problem here actually, 2-wire plug is not polarized. There's no ground, so this power supply is not very safe. So I'd like to make that a 3-wire plug. So I've got a lot of changes to do. So instead of this kind of small case, it's very compact. I have obtained a new case that is clamshell. Let's put this together. And it's much larger. Maybe I can turn this. So you can see the new case is an extra 1.25 inches higher, and it's about 1 inch wider, and it's about 1.5 inches deeper. So there's a lot more space in this new case for the same components. So I should have no trouble setting up even a cooling fan. I do have a circuit for a variable speed fan controller, so I may build that into here. So basically the fan won't run unless it's warm enough inside the case, and then the fan will ramp up its speed depending on the temperature. So this case came with these nice end panels that will screw in, and I'd like to try to keep the face and the back of this new power supply much less scratched up and bent as the old one. So that will be a challenge to drill square holes in this. And I need square holes because I have obtained a brand new voltmeter, which is 0 to 15 DC, and a new ammeter that is exactly the same size, same manufacturer, that is 0 to 5 amps. Perfect. Thing is, these actually don't take square holes. They take a round hole, and then the screws have to come through another hole in the right spot to mount this meter flush with the front. And also, since these meters are a little bit deeper than the old meter, it's nice to have a little bit longer case. So these guys will fit just barely on the front, and it's going to be very compact, so I may end up having to move the on-off switch and the pilot light and the potentiometer somewhere else. I think there's a fairly good chance that I can fit all 3 of those below or above the meters. So it's still going to be a little bit tight on the face, but it should work out fine. In working with the front panel, I had to come up with a way to fit both of these meters on the front panel, and making the holes for them was kind of I had to be careful. I only have one of these enclosures. They're not really inexpensive, and I can't buy a new panel, so I wanted to take the safe route to make these holes. So I ended up with a panel like this. Ended up putting masking tape over the entire front and marked lines where the center lines of the holes were, and all the locations of the holes with the crossing lines. So this just has masking tape on it, and you can see the holes came out very nice. So these holes on the bottom I just drilled out with a metal drill bit for drilling metal bit, and put a little bevel on the inside with an end mill. You could also use a larger drill bit for that. And just to make it flush, so the components from the back will sit flush. So let's take the tape off, see how the front came out. The holes were all drilled from the front. See, the edge of that hole is very, very nice. There's no scratches on the front. So we will take the rest of the tape off later. And basically these meters will fit right in here. And they will be like that. That's just lovely. And then the holes here, I decided to put the switch here and the LED there. And this will be for the adjustment knob, the potentiometer to set the voltage of the output. I also decided to stick with the 2 amp power supply limit because the transformer I have is a 2 amp transformer and I really don't want to replace that, and I really don't need more than 2 amps, but what that means is I'll never use the upper end of that ammeter, and that's fine. Turns out I could not find one that was in the 2 amp, 3 amp range. I had to go with the 5 amp. So that's what that looks like, and that's going to be just wonderful. Here's the finished front panel, except for the holes here need a little bit of trimming up with that large drill bit or end mill, so I will be doing that when I'm done filming here. And you're probably wondering how I cut such large these are 2-inch holes. How did I cut such large holes and have the edge, come out just very clean? And the answer is I used a very quickly made template. This is just a piece of plywood that is 1/4 inch thick. And this is a piece of scrap out of the wood shop, and I took a Forstner bit that I happen to have, and I chose a 2-inch size because the back of the meters has a little 2-inch raised area here, so that has to fit in the hole. And so I made the template to fit that, and then I had marked this, of course. Made the template over it, centered it where the marks, center line of the marks were, clamped it down to the workbench, and ran my router, my little 1 horsepower small router with a flush trimming bit for countertops with carbide edge, and ran that around and took out all this material. And the way I got the router bit through the initial aluminum solid face was I had put this on the drill press and drilled a probably slightly larger than 1/2-inch hole so that I could put the drill bit down in there, the router bit down in there, and start working away that material within the template. So that's how you can make a hole where you want it with a nice smooth edge. No filing needed.